So we are, it's about 12:30. We're going to step into our second session on going all electric this morning. And I'm very pleased to host that. My name is Damian Moyes. I'm the Policy and Research Manager at Renew. And we've been looking at all electric homes for a long time. I've been with the organisation over 10 years, and I recall when first starting, we were looking at the different pathways, whether or not all electric homes were going to be the way forward, and doing lots of research and sort of some advocacy around that. And it's just amazing over the last 10 years to see how many new homes and existing homes, and the general kind of trend towards efficient all electric appliances powered by on-site renewable energy. So it's a topic that's a real passion of mine and of the organisations, and I'm very pleased to host this session right now. So we once again have a great panel for this session, 4 different panellists and 4 different homes from across Australia, a couple from in suburban Melbourne, one from WA and one from New South Wales, and different types of homes and projects, new builds and renovations. We've got an owner builder in there, and some pretty interesting aspects to these homes. So without further ado, I'm going to introduce each of the panellists for the session, and they're going to give a small 1 or 2 minute just introduction on their home and their project. So I'm going to throw to Rebecca Nelson first, who is the person associated with the Pond House in Moonee Ponds in Melbourne. Good morning or afternoon, Rebecca. Would you like to give an introduction?
Sure, thank you. So our house is the Pond House in Moonee Ponds. It's a volume built house. So our story is that we bought the land for the house that had a Californian bungalow on it from the 1920s, not quite realising how much it would cost to renovate a house, and it was just not feasible for us. So we ultimately went with a new build with a volume builder. There were a few reasons that we went with the volume builder. One was cost. Another was that we found a volume builder, Henley, who had an in-house sustainability manager. And so that gave us the opportunity to kind of take a really iterative approach to sustainability, tweaking the floor plan, in some cases more than tweaking, changing quite a lot the floor plan, and figuring out what that would mean in terms of energy efficiency. Also, they were really keen on air tightness, which we thought was really important to the house for energy efficiency, even though that's not necessarily reflected in the energy ratings. So it's an all-electric house. For heating and cooling, we have 6 Daikon Ururu Sarara split systems. We've got 5.3 kilowatts of solar panels and a Tesla 2 battery. In terms of heating and cooling, we do definitely use the heater during winter. On the hottest days of summer, we also use the air conditioning. But for us, a really important decision point for that system was that it included ventilation, which for a relatively airtight house is really important. So yeah, that's our story. I'm happy to answer some questions.
Fantastic. Thank you, Rebecca. Our second panellist is Romney Bishop. Welcome, Romney. And your home's titled Our Comfy Home. Do you want to tell us a bit about your place?
Yeah, sure. Thanks. Hi, everyone. I'm Romney. I live in the outer northeastern suburbs of Melbourne. And our house is a 1984 concrete block house on a slab with a flat roof on the side of a hill. Pretty challenging. My husband and I moved in during that heat wave in January of 2009. It seems a long time ago now, but the memory of how hot the house was during those first few weeks still makes me shudder. And as does the memory of the next few winters when we were shivering every day, not able to get it warm enough to be comfortable. We loved the style of the house. And we didn't want to pull it down. We were concerned about the waste of resources if we pulled it down to build a replacement, so we decided to renovate instead. There was a wood heater in the back of the house when we moved in, but it was at the opposite end of the house to the living area, so not very useful. Our energy bills at that time were about $3,800 a year. Now they're about $360 a year. And we've made the house really comfortable to be in year round. We're planning to install some batteries early next year, which will make us pretty well self-sufficient. And along with installing efficient appliances, we put as much insulation into the roof and the walls as we could. And we made sure the house was well sealed and changed our windows over to double glazed units. And I think there are so many good reasons to go all electric, which is why I'm on the panel today.
Great, thanks Romney. Our third panellist is Matt Saxon, dialing in from WA. Over to you, Matt.
Apologies, just fumbling for the mute button there. So our home is in Mount Hawthorn. That's a inner city suburb in Perth, about 5 kilometres sort of basically north of the city centre. It's a new build, so there was an existing 50s house on it, fairly typical Australian construction, extremely inefficient one, and not laid out in such a way that it was worth the cost of renovating it. So we went for and I should say, unlike some of the other houses, not at all a challenging site, pretty much almost flat and just sand. So our objective was a sustainable family home, solar passive. It's basic slab on ground. We went for a lightweight timber frame construction. That's both cost driven and also energy inputs, but it's also architecturally designed rather than not a kit home at all. Although I fully support the idea of building homes through volume builders if you can to save money, but it's not an option that's available in Perth, unfortunately. Continuing with the construction, so it's, as I said, slab on ground, lightweight construction, clad in timber and colorbond. Primary drivers, environmentally, very much a climate change thing for both of us, I and my wife. Particularly interested in things like marginal carbon dioxide abatement costs. So within certain limits, not compromising on some things. One of the objectives in building the house was how can we make our money work most effectively to combat climate change. After all, if you spend an extra $1 million on your house, you could have maybe combated climate change more effectively with that $1 million. In terms of other features though, it's got a 5.6 kilowatt photovoltaic system. Hot water is from a heat pump and the cooking is induction, and LED lighting without. As I said, all electric. I was very keen to go all electric from the beginning because I felt it was better for the environment and would prove to be cheaper.
Great, thank you, Matt. And our fourth and final panellist is Charles Price, who's an owner-builder and has done a new build project in New South Wales. Welcome, Charles. Do you want to tell us a bit about it?
Thanks, Damien. After building 5 times as an owner-builder, I thought our last home, earth covered in the Lower Blue Mountains, was as good as it could get. But family ties pulled us back to Sydney, where a rogue builder left us in the lurch. So at 80 years of age, I had to pick up the pieces and do it all again. With great help from Dick Clark at Envirotecture, we designed the most efficient energy home we could afford, which is outlined in the specs available online. However, there are a few features I'd like to draw attention to that need updating and probably are the key points to talk about anyway. The house area stated is only 214 square metres, and that's the top floor only, but there is a lower floor which is an additional 108 square metres, and then garage and underfloor decking with another 145 square metres. So it's bigger than it looks. The cross ventilation system uses the prevailing nor'easter from the north to south walls by using curved ceiling and lowered internal partition walls. Also, Lunos heat recovery units in pairs to each of the 3 ventilation zones, that is the main living and the 2 bedroom wings, and high ceiling fans are additional controls to that system. The whole site is subject to water control known as SUDS, which stands for a Sustainable Urban Drainage System. with 40% water saved to our water tanks and 50% passing through the gardens, which contain over 800 native plants. The external wall insulation uses 75mm EPS cladding with isonine sprayed insulation, internally giving a net R factor of 5.9. The Energy Star rating of 5.5 was shown on the specs, was prepared on the initial modular build that went bad, but as Envirotecture points out, it is considerably higher now. It hasn't been retested. We are not connected to the grid, but we belong to a large energy sharing network called Sonnen Flat. Our batteries are Sonnen, which gives us a much better deal when arguing about feed-in tariffs. We have cost nothing for all our power for a year. Our system generates 5 and a bit kilowatts per hour when the sun is shining. So on a normal day, we generate over 30 kilowatt hours, much more than we use. Living on a steep slope, that is from the entry, it's 14 metres to the top. So we have a 3-person elevator, which is great as one ages. Our colorbond roof is a very light colour, reflecting a large percentage of the solar radiation, something that people often don't think about. One point to close, the cost was shown as $550,000 for the original modular build quote, but the actual building cost was somewhere between $900,000 and $1 million, not including my labour. That's it.
Great, thanks, Charles. So we've got about half an hour. We're going to work through Q&A session again. So please, for attendees, if you can put your questions into the Q&A button or into the Q&A window in it. We're looking at those primarily. We're not using the chat function for questions and answers. If you've got any technical issues, you might want to use that, or comments, but to ask questions of our panelists, please use the Q&A box. I'm going to ask a general one to kick things off, and I'm going to go back to you, Charles, just given the nature of your project. And I wanted to ask you, overall, what was the biggest challenge that you faced with the project?
The site was obviously the first important thing, and we have a full steel frame construction, which adds considerably to the cost, but has proved to be beneficial. I'll just leave it at that one.
No worries, thank you. One for you, Romney, here from Donna. Interested in the double glazing option. Why did you choose that, and why?
It was partly for energy efficiency reasons, and partly because our bushfire attack level rating is quite high. So we're required to have strengthened glass and metal screens over any openable windows. But it was more because our previous windows gave us a lot of grief because we got a lot of condensation on them during winter, because it gets pretty cold at night here. So we wanted to make the building as efficient as possible, as well as the appliances. So we went for some pretty whiz-bang windows, so double glazed, argon filled and low E coated in timber frames.
Great, thanks, Romney. One for you, Rebecca. What was the decision to use the Daikon reverse cycle system based on?
So it was really based on the ability to have heating, cooling and ventilation all in the one unit. Price-wise, that was by far the best option compared to having separate ventilation systems for us. We've got separate split systems, so we don't have any ducting. And the reason that we wanted that is because ducting, we were advised, is a real problem in terms of air tightness. So we essentially have a zoned system where the doors that we've chosen, the placement of the doors in the house are such that we don't really ever have all of the split systems going at once. We just use them in the part of the house that we're actually occupying at any given time. And just to give you a sense, I think our average daily consumption, which is primarily through those systems, is about 15 kilowatt hours per day. And our electricity bill is about $500 a year for the house.
Amazing. So I think a couple of you have heat recovery systems for the homes. For those that do, Brett here's got a question. Any strong recommendations about specific heat recovery systems? Are they capable of making heating and cooling obsolete?
Well, I'll throw in the point from, we have the pair of lunos in each of our 3 sections, which is an oscillating heat recovery system. I haven't been all that impressed because the contribution it makes is minor compared with the other controls that we have. I know Envirotexture favour them very strongly, my building designer, but I'm still not quite sold on the whole idea.
Fair enough. Other comments from the panelists on that one? No?
We chose not to put one in. We thought about it long and hard, but it was because we've got a flat roof. We wanted to put the insulation in as much insulation in as possible, and we would have had to have run some ducting through the roof cavity and forsaken the insulation.
Yeah, okay. Question here about 3-phase power. Do any of the panelists have 3-phase at their site? And if so, maybe you'd like to make some comments around that?
Yes, we have 3-phase power, but I have a major workshop because of all the work that I've done. So I wouldn't go back on that. Also, if a phase drops out, you've still got the other phases to work. Occasionally that could happen.
Yep.
Unless you want to draw more than 5 kilowatts at once, 5, 6, 7 kilowatts, there isn't really too much of a point.
Okay. Well, I've got your Matt question here. What systems can be used to ensure that an all-electric home is all solar and avoids grid usage?
Well, look, it is an interesting question. If you live in an urban area, you are better off not avoiding grid usage. At least that's my opinion, depending on what your objective is. It won't be cheaper to avoid using grid usage. And it's debatable whether you'd be deferring more carbon dioxide emissions being off grid if the grid is available. When you crunch the numbers, you'll find, probably going to find that the upfront energy, right, involved in sizing a battery system which is sufficient for you to be off grid is not going to be justified from the emissions you save from not consuming grid power. It's kind of the same as gas versus electricity, right? So the emissions inherent in gas are never going to change. Like when you combust 1 unit of gas, the amount of CO2 you produce is always going to be the same. But the intensity of grid power decreases over time. When I first started crunching the numbers for this sort of thing 5, 6, 7 years ago, the grid intensity in Western Australia was 0.76 kilograms of carbon dioxide per 1 kilowatt hour of grid power. Now it's down to 0.69. That's 10% in 6 years, and that's with the government actively resisting change. So if you've got access to the grid, what you should do is maximise your consumption. So you minimise your consumption by being clever about how you consume power. Look to use timers as much as possible to focus your consumption during the day when you're producing power yourself, and then just consume as little power as is practical the rest of the time. That's how our house is configured. So I know I'm monopolising the session, so I'll stop talking. I'll try and stop talking, but we consume on average about 4.5 kilowatt hours a day from the grid, and maybe a further 8 or 9 is consumed from the panels by pushing all our consumption into the middle of the day. The best thing for that is the heat pump hot water. It only runs during the day. it effectively means even in winter our hot water is essentially free. I could go on, but I'll squeeze my points into some other point down the line.
No worries. Thanks, Matt. One here from Ivor for Romney. Romney, what was your choice for retrofitted insulation for your home's roof space?
We chose PIR board in combination with some high density polyester bats. We actually had to increase the roof cavity size to fit insulation in because it was only at its tallest 100 millimetres in the middle of the building before the renovation. So with the PIR board you get a higher R value for the same size of insulation, so it meant we could fit a lot more in. So we've ended up with R6 towards the middle of the house for about 4 metres, and then towards the outside edges of the house it's about 4.5.
Okay. Got a general question here. It's actually quite a good question. I'll sort of throw it open to the panel, but maybe more relevant to some than others. But how do people feel about all electric homes and bushfire resilience? And Tristan here is specifically interested in water pressure. Someone want to take that one on?
It is a problem if you don't have your own isolated electricity supply. We're in that very situation where if the power goes off, we will not have water other than to gravity feed out of our tanks. That's the current situation. When we get batteries, we'll probably also put the inability to isolate from the grid so that if the grid does fail, we can at least still run our pumps. The other option for people is to have backup diesel generators in this situation where you can hook them up to your pumps and continue to get water. But I hopefully plan not to be here if that happens.
That's the standard. Like a mineral processing plant is all electric, but for regulatory reasons, the firefighting is diesel powered. And ideally, you're not going to actually be burning that diesel and producing carbon dioxide. It's only for if there's actually a bushfire.
Okay. Specific one for Rebecca here. For your pond house is running 6 Aruru. I assume that's the Daikon, the units. How many external heat pumps are required to run them?
So it's a 1-to-1, so we've got 6 externally. So you do have to be a little bit creative with where you put them because that's quite a few. But it seems to work pretty well. And like I say, we rarely have them all running at once.
Okay. Got lots of questions coming in here for Charles, so I'm going to throw a couple of these at you, Charles. This is from Jason. Can you explain a bit about your Lunos ventilation and how you determine zones? How does this work for bedrooms, and do you need one in each room?
You need 2 in each section. So from the outside wall from one side to the other, north to south, we have 1 in each, and they pulse in concentrated together. So as one is drawing in, the other one is expelling, and that reverses. It's quite an amazing system. You should have a look at it online sometime, Lunos. And the 3 zones we have, they are full height walls between the zones, but we're using the lower walls as partition walls so that the flow through of the air is not obstructed. It's as simple as that. But the Lunos system is very complex. It has to be cleaned once a month, and you've got to take out the unit and clean the filters. But
yeah. Thank you. And one more for you, Charles. Can you comment on the Sonnen Collective, how it works?
Yes, I said we're not connected to the grid. We're on the grid, but the Sonnen flat is like a separate controller, and it uses a number of people who are all with Sonnen batteries connected, and they manage the power. So we're like a minor power generator, and it all goes into one controller, and then we get power whenever we want, and it doesn't cost us anything. It's an amazing system. I was very sceptical before we joined. For the first 12 months, I didn't go with it, and then I realised that it had some advantages. And since joining, I think it's absolutely fantastic.
Great, thanks, Charles. Yeah, general one for the panel again now. Does anybody in the panel use automation for maximising the time of solar generation? If so, what applications? That's from Brendan.
Too difficult.
So we do use some basic automation in that the heat pump comes with a timer, an integrated timer, which enables it to be run on within a specified time period. I imagine the question is more about sort of the next level of automation where you're using smart home tools or other internet-based products to actually manage your generation and consumption. We probably will ultimately end up doing something like that, but it's there are costs involved and costs involved in that, and a bit of a learning curve involved as well. So we haven't quite got to that one yet. But just doing it manually with basic things like timers will pick up 80-90% of what you want to do, and then the rest of it's, becomes a bit of a marginal gain. So you think, well, if it costs me $1,000 for a smart system, how long is it going to take me to make that money back?
Thanks, Matt. Anyone else for comment on that one?
As an old dinosaur, I like to have my hands on the control because there are so many different areas to control to get the best. I think I can do it better than an automation one would at this stage.
Fair enough. Okay, let's move on. Here's a different specific question. Has anyone had any experience or used the FAR infrared heating panels in their projects? Looks like everybody's nodding their head. No.
We're actually masochists who have no heating or cooling in the house at all. That was one of the objectives of the design. Sorry, there are fans, but there's no heating. Yep.
That's good result. Look, I can say that personally I've used them before in projects. Interesting heating solution. They're certainly low. They're relatively low power, or at least the ones that were around a few years ago when I bought one was. Good for bedrooms, and you can sort of run them for a reasonable amount of time without incurring too much energy use or cost. But yeah, sort of for specific situations. A few questions here on hot water systems. General one to the question, did any of you weigh up electric tank versus tankless water systems? Romney, do you want to go with that?
I did have a look at tankless electric system, but you need to have three-phase power for that, and we didn't want to put three-phase power on. So we actually had changed our previous electric storage system over to solar with an electric booster not that long before we started the renovation, so we decided to keep that. But if I had my druthers, I'd just go with a heat pump and run it from the solar now.
With that point source heating, so it's instant hot water to in separate unit to each room, you would probably almost certainly burn less electricity, but you would be burning it at times when you can't cover it with your solar panels. That's the difference. So your heat pump or your storage system might be less efficient, but it's zero carbon and zero cost electricity that you're burning.
Yeah, yep, I think that's right. Another one here on hot water. Would it be possible and cheaper to power a traditional electric water heater with a tank from solar power during the day? I'm unimpressed by a tube system in current rental in the subtropics, and heat pumps are a bit expensive to purchase. Yeah, Matt?
I've actually thought about this exact topic. I reckon the answer is yes, dependent on the cost of the hot water system you buy, right? So you can actually buy them now. So I know in Western Australia, there's one model available where it's basically just a good old fashioned electric resistance hot water system, storage system, which enables you to have basic integration with the solar hot water, with your solar system. So it's only consuming electricity when the solar panels are on. So the flip side it basically functions the same as a heat pump from a practical point of view, but consumes 2 or 3 times as much power. So then it becomes the trade-off between how much excess solar power you have as opposed to the cost. So basically, if your solar system's big enough and you can buy the resistance hot water heater that has the appropriate integration tools with your panel and the timers and such, and it's cheap enough, then I think it possibly is the way to go. It's got less moving parts. That's the thing about my heat pump. It consumes very little power, but I'm concerned about whether the thing is going to last more than 7, 8, 9, 10 years, whereas a very simple resistance heater, I think you can guarantee that'll go as long as the tank goes. So yeah, I think it's a good idea if it's cheap enough.
Could I comment on that? I introduced quantum heat pump for all hot water in our previous house. That was in 1999, put that in. And when I left that home in 2018, it was still absolutely fantastic. So I think longevity of it is great. And the cost of the heat pump may be a little bit dearer to buy, but you certainly regain that in a fairly short time in the cost of heating if you use a normal electric heat pump. Electric heater.
Yeah, yep, absolutely. Romney, I wanted to ask you a bit about your project in the notes that I read on the website. So your project, you ended up going from a fairly typical, 1.5, 1.6 star existing home up to 6.3 stars. Is that right?
Yeah.
We do lots of analysis and research on new homes and existing homes over the years, and to me, it's always been very difficult to get existing homes up beyond much more than about sort of 3.5, 4 stars. Can you tell us a bit about, what some of the main things were that you did to actually get that rating so high?
Yeah, it was tricky, and it took a bit of thought and a bit of scenario planning using the First Rate 5 software, because to the north of us we're pretty close to the neighbouring house and the view's not all that spectacular. So we did toss around whether we would put in some clear story windows into the living area and so on, but it really came down to cost in the end. And you can talk about all sorts of potential solutions, but you've got to just make a decision within your budget in the end. So we were able to insulate all the external walls of the house, which has made a huge difference, because we used to sit near an external wall, which is the bagged concrete block, and you could feel the heat being sucked out of the back of your neck. It was terrible. So we made a decision to insulate all those walls, and we used PIR board with the plasterboard attached, and just used masonry glue and stuck it straight onto the wall, it's worked really well. And the roof insulation combined with the windows are the other two things that probably may have made the biggest difference.
Okay. Yeah, great. And Rebecca, I just wanted to ask you also about the sort of biggest challenges that you kind of faced with your project, and particularly your learnings and what you might do differently next time if you tackled a similar kind of project.
So, I'm pretty pleased with the result that we got in terms of energy efficiency. So, I mean, ours is at 7.5 stars, but equally we were quite constrained because we've got quite a tall house on our northern boundary, also not spectacular views out of our northern windows. I think if I had to change anything, it would be putting in more northern windows that by regulation have to be obscured because of the fact that we'd be overlooking the neighbouring house. At the time that we built the house, we didn't want to do that, have a lot of obscure windows, but I think I probably would have done that in hindsight, just to get a little bit more light in compared to what we do have in our upper stories where the regulations apply. That's one of the few things that I think I'd change. I mean, perhaps if we wanted to build a different kind of house, we would have positioned the house such that it was a much skinnier and longer house so that we got a little bit more northern light. But I think those are the main things that I'd change. And ultimately, I'm pretty happy with where we've ended up.
Great, thank you. We've got a few minutes left until we need to move to the next session. Got a specific one for you here, Charles. This is from Craig. What was your sprayed insulation brand? What was it made of?
It's an isonine, which is a Canadian product. It's a PIR, as Romney had used fantastically on their house. I congratulate her on the way she had done that. That's a real gem. But the PIR is we sprayed on, and as a result of that, we have no leaks. I have talked to my building designer about continuing on and doing a pressure test to see what our leakage is, but it's not at the moment. I will. We have louvered windows in 2 of the bathrooms, and that would be a problem. But everywhere else, we've used this on the roof, in the walls, and under the floor, so we are almost completely sealed. It's spray on. It's a bit of a messy job when they do it, so you wouldn't want to do it in a finished house, I don't think. But it sprays on to it just explodes up like any normal foam spray, and locks it in. It's amazing stuff. Isonine, ICYNENE. Have a look online for the guy who was asking the question.
Great, thanks, Charles. A couple more. Matt, just wanted to ask you about, given the high performance you achieved with your project, just whether you think that the mechanical heat recovery ventilation type systems are necessary at that level.
I think it's entirely dependent on your local climate. So Perth, climate's pretty friendly, you know. Okay, so it gets hotter in summer, but it's not like it's 40 degrees 30 times. Maybe it only happens half a dozen times. Maybe call me back in 30 years about that. But for the moment, it's not that regularly stinking hot. And in winter, it's cool, but you're not spending that much time where the delta T between the inside of the house and the outside of the house is more than 5, 6, 7, 8 degrees. So because we have conditions where solar passive is very suitable, then basically once you go slab on ground, insulate the house solidly enough, then without having to condition the air, whether it's via an internal heat pump or via an energy exchange system, you just don't need to put it in. I think if you wanted to get a really comfortable, totally comfortable, so go back a step, I'd estimate that our house is between 18 to 26 degrees, which I think is the NATHERS framework for the acceptable temperature limits. It's between that 97, 98% of the time throughout the year by itself. So that it does mean at the tail end, right? So some days it's getting a little bit cool on the old feet, and if it's hot enough come February, it's getting a touch warm. That's fine for us, but if you're older or in ill health, maybe you wouldn't want to be in that situation. And I did think about it, that if your house is well sealed enough, then whacking a mechanical heat recovery system in rather than air conditioning might just keep the house comfortable 100% of the time. But they are extremely expensive.
Thanks, Matt. We'll try to do one or two more. One here for you, Rebecca. Specifically, this is from Sandy. Did Rebecca find that using a volume builder helped or hindered implementing the sustainability features she wanted?
Both. Mostly helped. So we had a really experienced and just a really good advisor as our sustainability manager, but the volume builder that we chose, Henley, was the only one that we found that actually had someone in-house. I think had we gone with a volume builder where we were talking to a sustainability person separately and trying to change house plans in accordance with that advice and test things in terms of energy efficiency, it just would not have worked. So I think having an in-house person was really good. In terms of the hindering, there was some stuff that we wanted to do that we were just told it just doesn't work with a volume build. So we wanted to have internal bricks for thermal mass. That's not something that was possible. We were interested in having a polished concrete floor rather than having to put tiles over the top. That also wasn't something that was possible. We wanted to have some fancier windows than we ultimately had. So I was interested in some of the windows that would have enabled better ventilation rather than sort of an awning style. We still got to have double glazed low E argon filled windows, but they weren't quite the style that would have been the best ventilation wise. So I think we gained things and didn't gain things, but for the result that we got, I don't think we could have done better in terms of the cost that we paid for the size house that we got. I was overall pretty impressed.
Great, thanks, Rebecca. Well, I think we're at time, so we're going to have to draw this session to a close. Thank you to all the panelists for that session. That was absolutely fantastic from my perspective. Hope all the listeners got something out of it as well. We're going to again have a 5-minute break, play a bit of a video. If you're looking at what else is on the program for this afternoon, please go back to the SHD website, and you can even post questions on there for the speakers that you've heard just in that session or even in the sessions before that today. So yeah, thank you. We'll be back in 5 minutes.